Hello students, in this session we will discuss about the instruction and instruction sequencing, types of the instructions and instruction execution and straight line sequencing, branching, conditional codes and generating the memory addresses. First we will take up the first topic, instruction and instruction sequencing, right? Okay, so computer will perform its task based on the program that will be stored in the memory. So that here the program is nothing but the instructions, machine instructions. Okay, so here to perform any task in the computer, it needs some set of instructions that is already be stored in the memory. Okay, so that set of instruction will be stored in the memory. So that is called as instructions set architecture. So set of instruction group, that set of instruction is called as instruction set architecture. Here computer will perform the 4 types of operations. Usually it performs 4 types of operation. In that first one it is the arithmetic and logic operations. Arithmetic and logic operation, and second one it is a data transferred between the memory and the processor, that is a second task. So data transfer, and the third one it is sequencing, program sequencing and the controlling. Program sequencing and controlling. Okay, and the next one it is input output operations. So to perform these operations, the computer will need the set of instructions or instruction set architecture. So in this instruction set architecture, how your computer will understand, understand the so it needs instruction set architecture. So how in this instruction set architecture the operation and operand will be represented. So in that we have 2 notations. We are using 2 notations. In that first one is a register transfer notation and second one is the assembly language notation. So first we see register transfer notation. First one is register transfer notation. Okay. So in this the memory location name will be represented as capital letters. So memory will be represented as like location A, LOC A, comma, LOC B, LOC C and all, or else A, B, etc. Okay. So next the processor registers. Registers will be represented as R0, R1, R2 and so on. Okay. So next it is a input output operations. In the input output operations it will be represented as like data in, data out and out buffer, in buffer, like that, etc. Okay. Here to represent the content of the location or content of the register by using the square brackets. So how to represent the contents? By using square brackets. Okay. So here after this take an example, C is equal to A plus B. How to write this in the register transfer notation? So here take an arrow In the register transfer notation, we are using arrow here. So, in the left side of the arrow, it will contain the destination, and the right side it will contain the memory location or source, right. It can be memory location, it can be register, but in the right side it will contain the source, right. Here C is the destination and A plus B source, right. So, C, right side it will contain C. Here you are adding the content of A with the content of B, right. So, for that I am writing like this, A plus content of B, right. Take another one example, right. Say for example, you want to move the data from say from A to register R0. How to represent this A to R0 in register transfer notation? Yes, here you need to find out the destination. R0 is the destination, right. So, for that right side it contains R0, right. In the left side it is a source. So, here A is the source, it is the content of A will be moved from A to R0, right. Okay, can you write move content from R1 to C. How to represent this in register transfer notation? Yes, in the left side first we take the destination, right. So, here C is the destination, right, C. So, in the right side it contains source, here R1. So, content of R1 will copy from R1 to C, right. Okay. Next you can say C is equal to R0 plus R1. So, here also C content of R0 plus content of R1. Okay, got it. So, here in the register transfer notation we are using capital letters to represent the memory. It can be memory name, can be anything. So, here I am taking simple examples for that, location A, location B, A, B, etc. So, for registers we are using R0, R1 and Rn, right. So, for input output operations, data in, data out buffer, in buffer and so on. So, the content will be represented by using the square brackets, and this is the examples for that. Okay. So, the second notation, yes, the register transfer notation, it is easy to understand, but we cannot write like this in the computer. So, for that we are using assembly language notation. So, next is the assembly language notation. Yes. So, in the assembly language notation, first we use always we use the operation and followed with the operands. Say for example, you want C is equal to A plus B, right. Here how to write this? So, for this addition we are using add. Add is the instruction, it is the operation, and add content of A with the B, right. For that we use different operand names. Okay. Say for example, this can be written as first you need to move this A content of A to the any register that will be present in the processor. Here I am taking R1 register, or you can take R0, you can take R2, no problem. Okay. How? Move. So, content of A to R0 or R1. Yes. Okay. Next add B comma R1, and again move R1 comma C. This is the instruction set. So, or else you can also write, yes, you can also write move move B comma R1. Yes, next is next is add R1, A comma R1 and move R1 comma C. Both are correct, right? Here first you need to move the content of A and store it in R1 and add the content of B with the content of R1 and store the result in R1 and move this R1 again back to the memory C, right? Here, yes, only this step is changed. Here move content of B to R1 and add content of A with the R1, R1 contain the value B, then the result again will be stored in the C, right? This is the assembly language notation. So, here the main disadvantage of the assembly language notation is it is not portable. It depends on the processor, right? It depends on the processor. So, the main disadvantages it is not portable. So, for that reason we are not using the assembly language, right. So, instead of that we are using the high level language to write the program. Here high level language, it is a machine independent. So, for that reason we are writing any program in a high level language, not in the assembly level language. Assembly level language, it is not portable, it depends on the processor. Okay. So, this is all about the instruction and instruction sequencing. So, the next topic is types of instructions. Next, it is a types of instructions. So, in this types of instructions, here it depends on this type, it depends on the number of operands, how many number of operands we are using or we are showing in the instructions. Okay. So, in that first one is a 3 address instructions. What is that? 3 address instructions. So, in the 3 address instruction, yes, the format for this, the syntax is operation and the source 1 comma source 2 comma and the last one is destination. This is the syntax for 3 address instructions. Example for this is C is equal to A plus B, right. So, here operation is addition. So, add, here source 1, right, source 1 can be A, right, A, comma source 2 it is B and the destination is C. So, we cannot directly write like this because you need to move this value into the register. So, for that reason I can write like this also, add R0 comma R1 comma C, right. So, in this example, so R0 contain A value, R1 contain B value, add these two and store the result in C. Okay. So, next is or else add R0 comma R1 comma R2. Here also add R0 R1 value and store the result in R2. Okay. So, here we are not using the 3 address instructions. Yes, it contains only one line, right. To addition of 2 numbers it contains only one line, but you cannot fit this into the one word in the main memory. So, for that reason we go with the second one, second type. Second one is a 2 address instruction. Yes, second one is 2 address instruction. Again, the format for this is operation, source, comma, here it can be source or destination. Okay, I will tell you why it is source or destination. Again, take this simple example, C is equal to A plus B. So, in the one instruction you cannot perform the addition of two numbers. So, for that we need several instructions. For example, move first content of A with the R0, right. So, here A is the source and R0 is the destination, right. Next is the addition, add B comma R0. Here you need to add, you need to take the two values, one from the B and another one from the R0. So, here B it acts like a source, yes, but R0 it is first it is source and add these two numbers and store the result in R0. So, here it can be act like source as well as the destination. Okay. So, next is move R0 comma C. Here R0 is a source and C is the destination. Here you need to store the R0 value into C. The result will be stored in C. Okay. This is the two address instruction. So, the next type is one address instruction. So, third type is one address instruction. Okay, here in the one address instruction, so first is the format as first is the operation and it contains, it may be it is a source or destination. Okay, source or destination. Here in the one address instruction format, so the other one is, so one is source, another one is destination, right. So, other one it is we are taking explicitly. So, your computer will take the other one. So, it can be source or it can be destination. So, implicitly here it will take the accumulator register. So, accumulator it is mainly used for arithmetic and logic operations. So, it is a special register it present inside the processor. So, what is that name? It is accumulator. Okay. Take an example, addition of two numbers, C is equal to A plus B. So, how to write this in one instructions? Say for example, move A. So, here you move the content of A to the accumulator register. Here it will move the content of A to the accumulator register, and the second one is add B. Here it will add the instruction. So, add is an instruction. It will add the content of B with the accumulator register and store the result in accumulator register. Okay. So, the next is move C. Here it will store the value result from accumulator register to C. Okay. So, or else it can also be write like this, move B and add A and move C. Both are same. Okay. So, first you need to take the A content and it will move to accumulator, and here add content of B with the accumulator, and next the store the result in C from accumulator to C, right, from accumulator to C. Similar way this is also same. First we take the we move the content of B to accumulator, add A value with the accumulator and store the result in C. Okay. This is all about the one address instruction. And the last type is zero address instruction. The last one is zero address instructions. Okay. So, in the zero address instructions, so both source and destination it is defined implicitly, right. So, here the operands value will be stored in the push down stack. Here the content or the operands will be stored in the stack. Which stack? Push down stack. So, in the assembly language we are using two address instructions. It is very familiar and it is easy. Okay. So, we are always using the two address instructions. Okay. This is all about the types of instruction. Next we will move to the next topic, that is instruction execution and straight line sequencing. Okay. Instruction execution and straight line sequencing. What is this? So, as we know that always the program counter it will contain the next instruction, it will contain the address of the next instruction to be executed, right. So, PC will contain the address program counter, right. Take an example, this is your memory, here this is the word, right. Take an example of addition of two numbers. So, first move A comma R0 and add B comma R0 and move R0 comma C, right. And so, the way A value will be stored here like that, and the B value will be stored here, and the result may be stored here C. Okay. This is the content of A. This location, this word will contain the content of A, and this location will contain the content of B, and this is the final result. C is equal to A plus B, right. C result will be stored in this place, right. Say for example, the address of this is I. Okay. The address of the first instruction may be I, and the next instruction, if it is a 32-bit word length, in that case what is the next address? It is I plus 4, okay, I plus 4. So, it is the next instruction address, next word, this word address, it is I plus, so add plus 4 here, right, it is 8 and so on, right. So, this address may be this A value may be stored in another location, this is in another location, and C for result it is in the another location, right. So, here this is the instruction to compute the addition of two numbers, and this is A and B, this value, right, A and B value will be stored in this location and this location, and after the computation, after the addition of two numbers, the result will be stored in this location, right. Always initially the PC will contain the value I, address of I. So, always the program execution begins in this location, from this location, right, I. So, PC will contain initially I, and we move this whole instruction into the processor. So, in that MAR and MDR, right. So, MDR memory data register, it will contain, first it is move, and move is yes, it is the instruction. Yes, you will identify this is the instruction, and it will send this move instruction to the IR, instruction register. So, once it moves IR, move into the IR register, your program counter value will be incremented. So, now in the second time it will contain the I plus 4. Now, PC will contain I plus 4, and next it will take the A value. How to take the A value? It will search the content of A in this memory location and find out the location, and it will take the data from the memory in this memory and store it into the register R0, right. So after that again it will check, so PC contain the next instructions, right, next instruction address, so that is I plus 4, right. So here it will execute sequentially, that's why it is called as straight line sequencing, that's why it is called as straight line sequencing, executes one by one, one after the other, right. So here also add is the instruction, move this add instruction into the IR register and they take the content of B and search it here and take the content of B, say it is 2, 3. So again 3, add 3 with the R0 contain value 2 and add 3 and 2, right, that is 5, and store the result in R0. Again the R, once this add instruction will move to the IR register, this PC value will be incremented. Now the PC value would contain the I plus 8. So after the execution of this instruction, it will move to the next line. That's why it is called as straight line sequencing. So here major work or the straight line sequencing will be done by using this program counter. Okay. So the next topic is branching. So what do you mean by this branching? Take an example, addition of n numbers. How to write the addition of n numbers? How to write the instruction set for addition of n numbers? So for that, so take an example, branching, addition of n numbers. So here sum, right, sum, okay, sum is equal to num1 plus num2 plus and so on num n, right. Here how to write this in the instruction? So for that, say for example, yes, this is your memory, right, this is the word. Here first move num1 comma R0, num1 comma R0. Next add num2 comma R0, add num3 comma R0, like that, add at last add num n comma R0 and the last one, which is that it is move R0 comma sum, right. Here it takes more number of memory words, it occupies more words, right. So to avoid this we are using branching instructions, right. So branching instruction, so in the C programming language we are using while and for loop, right. Similar way here also we are using branching instruction. Take an example in the branching instruction, first move n is the n numbers, this n numbers, n value, that will be moved to R0, then first value num1 value will be moved to num1 comma R1. So after this we are using the branching instruction or looping instructions. So after this here, so after the addition of first number with the num1 addition of num1 with the num2. So next you need to decrement, here you need to decrement the R0 value if the branch, if the here branch value is greater than 0. If this condition is true, then go to the label, particular label, that label name may be loop. Here this is the loop label. So this instruction will be executed n times, right? This is called looping statement. So this can be anything. So here what is this branch? This branch is nothing but this R0 value. So say for example 1 plus 2 plus 3 plus 4, right? Here what is the n value? N value will be 4, n is 4, right? So initially R0, you move R0 n value to R0, then R0 also contain the value 4. So now move num1. What is the num1 value? 1. 1 will be moved to R1. R1 will contain the value 1, right? So in this it will contain, for example, add num, we don't know the number, right? Num, here it will incremented, right? Num2 comma R1, right? So num2, what is the num2 value? It is 2, right? 2 plus 1, it is 3, and store the result in R1, right? Again decrement the R0 value. Now R0 will contain the value 3, right? R0 will contain value 3. Again check the condition, 3 is greater than 0. Yes, condition true. If the condition is true, again go to the particular label, label name is loop. Again go back here and add num3 comma R1. Num3 comma R1, here num3 value is 3. 3 plus R1 value is 3. Now R1 will contain the value 6. Okay. Now decrement the R0 value. Now R0 value is 2. Okay. So next is again check the condition, 2 is greater than 0, yes, condition is true. So go to that particular label. So again add num4 comma R1. So now decrement the value R1, yes, it is decremented, and this will be repeated in n times. This is the branching instruction. Okay. So the next topic is conditional codes. Okay, what is this conditional code? Here, yes, as we know that program counter will contain the address of the next instruction to be executed, right? So in this example, in the conditional branching or conditional looping statements, in that case, yes, execute this, yes, it will contain the, PC will contain the next instruction address, this one. So this one, after this, if this condition is, if the condition is true, in that case, if the program counter value contain the next address, then it will not be repeated n times. So for that reason, we are using the flags, conditional code flags. So conditional code flags is nothing but the flip-flop. What is that flip-flop? It is 0 or 1, right? Say for example, this is the conditional code flag. Conditional code flag is nothing but the register. Okay, it is a special purpose register. This is the register memory location, and it will contain 4 important conditional code. So that conditional code can be 0 or 1. So in that, first one is negative conditional code, overflow conditional code, carry conditional code, and the 0 conditional code. Say for example, negative conditional code. So in this operation, in this looping operation, in the each step, in the each pass, if the result of any addition or subtraction value, if the result will be negative number, in that case set this n value to 1, or else if the result of that particular pass result will be a positive number, in that case set this n value to 0. So next is the O. O is the overflow condition. Say for example 1 1, right? So in that case, say for example 4-bit addition, right? In the 4-bit addition, right. So, the capacity of the register may be 4 bit. In that case, the last one may be, see, addition of this is 0 and carry 1. So, this is the overflow, right, because your register contain, it can hold only 4 bits. In that case, this is overflow. How to identify the overflow? So, in that case, so if the addition of these two numbers, it contains any one overflow or one value carry. So, in that case, it will, this overflow bit will be set to 1. Say if it is it contains, say for example, addition of this number. Here you cannot identify any overflow here. So, in that case, this bit will be set to 0. So, next one is the carry flag. So, carry flag, say for example 1 1 0 0. So, in that case 1 1, right, addition of these two is 1 1 is 0 and carry 1. So, in the next step, in the next loop, so this will be the carry, right. How to identify this? In that case, the carry flag will be set to 1, right, otherwise it will be set to 0. So, next is 0. So, in this, so in the previous example, so what is the answer for this? It is 0, right. So, in that case, it will be set to, if the answer of these two, addition of these two will be 0. So, in that case, the 0 flag will be set to 1 or else it will be set to 0 if any number. So, in this case, the 0 flag will be set to 0. Okay. So, this is the conditional codes. So, the next topic is generating the memory addresses. So, in this looping statements, so this will be executed n times, right. Here you need to specify, we cannot explicitly specify the address of num1, num2, num3, num4. So, to represent that, we need different modes, addressing modes. So, in the next topic we will discuss about the different addressing modes. Thank you.